Hello, physical science students. Mrs. Smith here. We're going to delve into the wonderful world of energy calculations. You should have this handout in front of you. You should also have a calculator available. All right, Introduction to Energy Calculations. As the following table shows the common variables along with their units needed to calculate both potential and kinetic energy. You are responsible for knowing what each variable symbol stands for, as well as the appropriate units for each variable. Now, it may seem like that's a lot of information, but as we go through lots and lots of practice calculations, it will become much easier to learn and memorize. All right, let's look at the different variables that are involved. We have gravitational potential energy and potential energy, both of which are the exact same thing. We have GPE, PE. If you're reading a practice calculation, they're both referring to the same thing. We also have kinetic energy, abbreviated as KE. All of those are forms of energy, therefore they will all have the same units, which is joules, which we will abbreviate with a J. Next variable we'll see in our calculations is mass, which we will abbreviate with an M. And mass we want to be measured in kilograms, or kg. Now, if the problem gives you something else, like grams, then you need to convert into kilograms. We will also occasionally see weight. Weight will be abbreviated with a W, and we will use units of newtons. Where we see newtons before, when we're talking about forces. A weight is a type of force, so it's going to have the same units, newtons or N. Now, if you look at the little star, it says see below. Remember, right here, mass and weight are not the same thing. I know sometimes people like to use them interchangeably, but technically in the world of physics, mass and weight are two different entities. Your mass remains constant, while your weight may change due to gravitational force. For example, let's say you were to go to the moon. Your mass on the moon, your mass on the earth would be exactly the same, because remember, mass is a measure of the particles or the matter that's inside of your body. However, your weight on the moon would be less than that on Earth because the gravitational force on the moon is less. The gravitational force on the Earth is about 9.8 meters per second squared, whereas on the moon it's closer to 1.6 meters per second squared. So because the gravitational force pushing down on your body is less on the moon, you would weigh less on the moon. Last thing it says here is, if a calculation gives you mass, but you want weight, use the formula W equals mass times gravity. So if you know your mass in kilograms, just multiply that by gravity, which we just said was 9.8 meters per second squared, and that will give you your appropriate weight in newtons. And we'll be doing some labs where you'll be calculating that as well. Another variable we may see is velocity. We've seen velocity before. We know it's abbreviated with a V. We know it's measured in meters per second, or m/s. We will also see height, which will be abbreviated with an H, and height we want in meters. Again, if they give it to you in kilometers or centimeters or millimeters, you need to convert it into meters to make the equations and the formulas work. The last variable we're going to see with our energy calculations is gravity. Gravity will be abbreviated with a G, and it is going to be measured in meters per second, which we know is meters per second squared, or m/s squared. Hey, where have we seen that unit before? We saw that when we were talking about acceleration during our last unit. Remember, force equals mass times acceleration, and acceleration was always in meters per second squared. If you look at our little arrow here, it says G, gravity, is the acceleration due to gravity, which is why we see the same units as when we were calculating acceleration during the motion, or the balloon car unit. All right, there's our background information. Those are the different variables that we will see and the units involved with them. Now let's look at our actual formulas. First, we have this table showing formulas when calculating gravitational potential energy, or potential energy. Remember, it's the same thing. Now we have two sets of formulas. The ones on the right, or I'm sorry, the ones on the left say, if the information provides the mass or asks you to find the mass, use one of the following formulas. Our main formula is GPE equals mgh, gravitational potential energy equals mass times gravity times height. That's the main formula that we'll be using if they ask us to solve for gravitational potential energy or potential energy. Now, if you look below that, there's three other formulas, and you might be thinking, oh, that's so many formulas to remember. But remember, they're all just manipulations of the original formula. If we look at our first one, GPE equals mgh, and you're like, oh, well, what if I wanted to solve for mass? How would you do that? You would divide each side by GH, divide this side by GH, These would cancel out. What are you left with? Mass equals GPE divided by GH. Hey, look, that's one of the formulas on our list. Let's erase that there. Let's look at our next one. H equals GPE over mg. Same thing. If we look at our original formula, if we wanted to solve for height, we would divide by mg on each side. That would cause our m's and our g's to cancel over on the right. What are you left with? Height equals GPE over mg. Gravity formula is the exact same thing. It's just a manipulation of our first formula. So if you're thinking to yourself, which formulas do I need to know? Well, this is the one I'm going to give to you. When you take a test or quiz in this class, I will give you GPE equals mgh. You should know how to manipulate it into solving for these three other variables. All right, if you look on the right-hand side of our data table, it says if the information provides the weight or asks you to find the weight, use one of the following formulas, because remember, mass and weight are two different things. We have GPE equals WH. So gravitational potential energy equals weight times height. Now that makes sense because remember, we said weight equals mass times gravity. Now look over here. Mass times gravity. All of this is fitting together. So GPE equals WH. That is the standard formula that you will be given on tests and quizzes. But again, you should be able to manipulate it to solve for the other variables. So if you had GPE equals WH, and let's say it wanted you to solve for weight, how would you do that? You would divide by H on each side. And you'd get W equals GPE divided by H, which, hey, that's that formula right there. If you wanted to solve for height, you would divide by W on each side, and then you would get this formula. Again, you will get the main formulas. Let me erase all this real quick. So you will get this one, and then you should know how to manipulate them. All right, all of those are for gravitational potential energy or potential energy, which we know is the energy that is stored in an object. What if we're talking about the energy of motion? What if we're talking about kinetic energy? Then we're going to use this main formula right here. Kinetic energy equals 1/2 mv squared. Sometimes you will also see it, Ke equals 0.5 mv squared. Same thing, 0.5 is the same thing as a half. So in your calculator, it might be easier just to put 0.5 instead of 1/2 as a fraction. All right, let's look at this a little bit closer. We know that Ke is kinetic energy. 1/2 is just 0.5. We know m is mass. So far, all of that's pretty standard. But then we've got this velocity squared, v squared. Please note it says only the velocity is squared. And if you haven't talked about squares very much, squares just means you're timesing it by itself. So for example, let's say the velocity of the object was 5 meters per second. When you plugged that into the equation, you would want to square the 5 meters per second. So what is 5 times 5? Well, we know that is 25. So when you're solving for kinetic energy, you will have to square just the value of the velocity, which means you multiply it by itself. So you are not squaring your entire answer. You are only squaring the velocity. All right, let's look at the formulas that are underneath there. Again, these are manipulations of the original one, but because students haven't had a lot of experience with squares and square roots, I will give you all three of these equations. I do not expect you to be able to manipulate them by yourself. So let's look at the second one. The second one is mass equals 2 times the kinetic energy divided by the velocity squared. Note the squared again. Are we squaring all of the numbers? No, we are only squaring the value of the velocity. All right, let's look at the last one. V equals the square root of 2ke divided by m. What does that mean? First of all, we're solving for velocity, which we know is speed in a given direction. The first thing we're going to do is take 2 times the kinetic energy that they give us in the problem. We're then going to divide all of that by the mass. Our final step is to take the square root of it. So we want to take the square root of our entire answer. And if you look right here, our note, it says use your calculator to determine the square root of a value. Just like multiplying is the opposite of dividing, a square root is the opposite of squaring. So to undo a square, we're going to take the square root of it. You really just have to use the button on your calculator. It would be something that would be very difficult to do by hand unless it was like one of the perfect squares. So after you find this entire value, 2 times kinetic energy divided by the mass, then you will take the square root of that entire answer. That will give you your velocity. All right, that is all for our formulas and variables. Up next, we're going to talk about some practice calculations. That will be on the next screencast. So if you go back to the classroom website, please click on the one that refers to the practice calculations.